Hi, I'm Adolph Oliver, and this is the video clip that deals with word problems that are talking about how things are moving, motion. So, one of the things about these motion word problems is they give you a good glimpse of the power of the real algebra. What you can do is use information about the problem where you don't know the actual numbers, but you can build that into the equation and then come up with a solution. Now, first off, what is the basic equation here for motion? Well, it's simply D equals RT. Okay, D is the distance you've gone, R is your rate of speed, and T is the time. Now, you've often used this equation. If you're just driving down the freeway, for instance, at 50 miles per hour, that would be your rate of speed, and you go for 3 hours. Well, when you're going for 3 hours, 3 times 50 would be a total of 150 miles that you travel. Well, that's exactly what this equation tells you to do. Take the 50 miles per hour times the 3 hours, and that equals the distance you go. So you've probably been using this and not even realizing it. Now, many times when we're working on this, what we do is we have to rearrange the equation not for D equals, but for R equals or T equals. And of course, we can do that by interchanging the sides and then doing a little bit of algebraic solution to come up with it. But there's a quick way of coming up with this that some of my friends in electrical engineering showed me some years ago. And it involves doing this, making a triangle. Here we go. Okay, here's the triangle. And we put a T inside the triangle to divide it up into 3 parts. So here's our triangle with the 3 parts. Okay, the basic equation, D equals RT, we write in. Here's the D, and then the rest of it, R and T, we put down next to each other. Okay, now, of course, here's how you come up with all the equations. Put your finger over the one you want to solve for. Let's say the D right here. So D then would equal, well, notice the R and T are next to each other down here. So D equals RT. That's the basic equation and the one you needed to know to set up the triangle in the first place. But now, look at what you can do here. Let's say you want to solve for R. Put your finger over R. R equals what's left, D over T. So here it is, R equals D over T, and we can do that substitution anytime we want. Likewise, if we want to find out what T equals, cover up T, and it equals D divided by R. Okay, there we go. Now, all these guys you can get by rearranging the original equation algebraically, but this is a slick little way here of coming up with the other relations. And this works with any type of equation. It has 3 variables in it, 1 on the left and 2 on the right, multiplying each other. Well, okay, now, how do we solve these problems here that we call motion problems, or motion, I should say? The standard approach to motion problems is to look for information like the distances are equal, or the total distance is, or the times are equal, or anything like that. You know something about those values, that they're equal or what their total is, but you don't know them individually. You don't have the numeric values for that. What you can do is start out with that information and then build the rest of it into the equation. Let's take a look at how this type of thing can be done. Okay, here's our first problem dealing with this. And here we go. Now, one of the things that's often good to do here is to make a sketch of what's going on. Let's read through this first. Sean and Julio left home at the same time. They drove in opposite directions. Julio drove 15 kilometers per hour faster than Sean. After 1 hour, they were 135 kilometers apart. find Shauna's speed. Well, you'd have to scratch your head on this basic math for a bit, but we can set it up algebraically. Here we go. Let's do this. This is home, and they're going in opposite directions. So let me sketch here. Let's say this is S over here, and this is J over here. Now, let's start putting some of the information down here. We want to find Shauna's speed. So let's make that X, and it's going to be in kilometers per hour. Julio is driving 15 kilometers per hour faster. So we'll make him X plus 15 kilometers per hour. I'll put parens around here just to remind you that's the whole thing. Okay, now the next thing we can take note of here is that we don't know what these individual distances are, but after 1 hour, they were 135 kilometers apart. So we know this total distance is 135 kilometers. And the other thing we know is that the time here was 1 hour. So T equals 1 hour. And of course, remember they left at the same time. So that means they're each driving for 1 hour. Okay, well now, let's take a look at what we can do with this. Okay, the speeds, we know some information about X and X plus 15. The individual distances, the only thing we know is the total. And so this is the place to start this one with. I can say the distance that Shauna goes plus the distance that Julio goes equals 135 kilometers. Remember the total distance, 135. Well now, what we don't know these guys, but we do know that adding together give us this. This is where we now make a substitution using our motion equation. We're going to replace D with what D equals, and of course remember, D equals R times T. So here we go. What I'm going to do is replace each of these D's with RT. But I'm going to put the subscript here to keep track of who's Shauna and who's Julio over here. Julio is going to be R sub J, T sub J equals 135. So here's the power of doing this. We know that the two distances equal 135. Now we simply replace D with what they equal, RT, and we got information about these guys. Okay, for instance, the rate of speed for Shauna we have down as just X. The time, well, they're both going just 1 hour, so there's the time, plus the rate of speed for Julio, X plus 15, and he is also going just 1 hour. And of course, that sum still equals 135. Okay, well, here we are on this. Now what this means is we can turn around and solve this equation to come up with our answer for X here. X times 1 is just X, plus now we're going to distribute the 1 in. That's not hard to do. 1 times X is X. 1 times plus 15 is plus 15, and that equals 135. Well, now we're getting closer to the solution on this. I've got 2x over here plus 15. I'm going to simplify the side here. Now, of course, I got to jump the plus 15 over to the other side where it becomes negative 15. So that means now I've got 2x equals 135 minus 15 is 120. Divide both sides by 2. I get x equal to 60. X equals 60. And of course, remember, this is Shauna's speed. Remember, we made Shauna up here originally X. Here she is. And that's really what they just want us to find out here. But we can also find out Julio's as well. So this is Shauna, okay, and kilometers per hour, okay. Now remember, Julio was x plus 15, so we take the x value, which is 60, and add 15 to it, 75 kilometers per hour. This is what Julio is doing. Okay, well, here's our first example. And remember, we said very commonly what you want to do is make yourself a sketch to begin with so you can see what's going on and label the information down there. And then you can decide how to start out. In this particular problem, we knew that the two distances added together equaled 135. So that's what we started with. And then you use a substitution, the d equals rt, and on we went from there to come up with our answer. Okay, well, let's look at another version of these guys. They come in lots of different flavors here. Okay, let's look at this one. Here we go. A jet flew to Dublin and back. The trip there took 5 hours and the trip back took 11. What was the jet's average speed on the trip there if it averaged 165 kilometers on the return trip? Well, okay, let's make ourselves a little sketch here again. This we'll call the start. They don't say what the city name is, but anyway, here we go. We're going over to Dublin. Okay, then we turn around and fly back. Okay, so a jet flew to Dublin, here it is, and back, there that is. The trip took 5 hours. Well, let's put this down. Total time, T total, I'll just write total here, equals what they say, 5 hours. Okay, and the return trip coming back took 11. Okay, here's the return. So we know it's 11 hours. A trip there took 5 hours. Here we go. 5 hours a trip there. Let's make sure we get this right. Okay, and the trip back took 11 hours. Okay, here that is. So 5 hours and 11 hours. Now, what was the jet's average speed on the trip there if it averaged 165 kilometers per hour on the return trip? Well, we're going 165 kilometers per hour here on the return trip, and we want to know what the speed is on the trip going over. So this is the one here that we ultimately want to get. But now, remember, the trip there took 5 hours and the trip back took 11 hours. Okay, what we have here is the one thing we don't know is what these distances are. Okay, so I do know the following that I can start with here. I know that the distance 2, I'll put 2 for going to Dublin, equals the distance coming back from Dublin. Okay, now we know that for sure. You find the same distance both ways. Well, once again, D equals RT. So let's make the substitutions here. D equals RT. Okay, but I'm going to put the T's underneath. These T's represent 2. This T here represents time. And coming back, well, D equals RT again. R coming back, time coming back. Okay. Okay. Let's turn around now and plug in the values that we have for this. Okay. So remember, the rate of speed 2, well, that's our x. So here it is. The time going to was 5 hours. Okay. The rate of speed coming back was 165 kilometers per hour. And here we go, 165 times, and just checking to make sure, it averaged 165 kilometers per hour on the return trip. So, yep, that's the return trip. And the time coming back, well, it said the trip back took 11 hours. Okay, so here we go. Now, this is an equation. We can solve for x and get that speed we wanted. Let's simplify it. 5 times x equals, now 11 times 165. Let's do that off on the side here. That's 165 times 165. We got 5, 11, 7, 8. Looks like 1815. Let's double check this. 65, 165, 5, 11 carry to 1, 7 and 1 is 8. Okay, 11 times 165 is 1815. Okay, well, now all we have to do is divide both sides by 5 to get our solution here. What is x going to equal? Well, x is going to equal, let's see, 5 goes in 18 3 times. That's 15, so we got a 31. 5 goes in 31 6 times, and that leaves a 1 and a 5. Looks to me, if I didn't make a mistake in the math here, that x equals 363 kilometers per hour. So that's the speed going to, okay, this is the speed to Dublin. Okay, well, once again, let's point out what's happened here. We made a sketch of the basic information here so we could better see what's going on. An airplane's flying from some starting point to Dublin and then back. It takes 5 hours to go to Dublin and 11 hours to come back. The speed coming back was 165 kilometers per hour. The speed going to is the thing we want to solve for. And so here we go. Let's turn around now and take the basic information. Distance to equals distance back. Do the D equals RT substitution. The reason we do the substitution is we don't have any more information about D, but we do have information about R and T. Well, okay, remember what we did, we just plugged these values in and then turn around and solve, and that allowed us then to come up with X being 363 kilometers per hour, the speed going to Dublin. Okay, let's look at one more of these guys. As I said, there are a number of different ways these can be phrased. So let's take a look here now at another example of doing this. Okay, here we go. This one right here says the following. It says, Jose left the mall 1 hour before Amani. They drove in opposite directions. Okay, well, here we go. Let's make our sketch. We're leaving the mall. So here's the mall, and they're going in opposite directions. Okay, so let's say that this is Jose going this way and Amani going this way. Your choice of how you want to set this up to begin with. But then after this, you've got to be standard in how you deal with all of this stuff going on. So here we go. Let's turn around now and say, okay, Amani drove 30 miles per hour for 1 hour. 30 miles per hour, 1 hour. Jose left the mall 1 hour before her, and we want to find his speed. So we'll say he is X miles per hour. And since he left 1 hour before, his total time is 2 hours. Okay, now, after we get all of that put together, we find out that after that time, the 2 hours that Jose went and the 1 hour Manny went, that they were a total of 90 miles apart from each other. Okay, so here we are, 90 miles. Okay, well now, the thing again here is we know what the total of the distances are, but we don't know the individual ones. So we could start out with the distance Manny goes plus the distance Jose goes equals the 90 miles. There's our starting point in this. Now, let's do the d equals RT substitution again. Since we're replacing d, we know that d equals RT. So R Manny T Manny plus R Jose T Jose equals 90. Now, these guys we actually have some information about, so we can do something. Okay, what's the rate of speed that a Manny's going? It's 30 miles per hour. How long did she go? 1 hour. Plus, what's the rate of speed that Jose's going? Well, that's what we're solving for, the x. And he went for 2 hours. And that, of course, still equals the 90. Okay, well, let's start cleaning this up. This gives us a nice little equation that we can solve for now. 30 times 1 is 30, plus 2x equals 90. Well, I got to take the plus 30 and move it over as negative 30. So I got 2x equals what, 60? Okay, divide both sides by 2. And looks like we've got our final answer here. X equals, okay, let's put it down here. X equals 30 miles per hour. And that happens to be Jose's speed. Okay, well, once again, what we did was we took the original information and we made ourselves a sketch so we could see what's going on. Jose and Manny left the mall going in opposite directions, but Jose left 1 hour earlier. Now, they say Manny drove at 30 miles per hour for 1 hour, so here's her. After this time, so after she'd gone 1 hour, well, if she'd gone 1 hour, Jose left an hour before, so that means he's gone a total of 2 hours, and we want to find his speed x. The only thing we know is the total distance equals 90, so that gives us our starting equation here. di plus dj equals 90. We turn around now and do our d equals RT substitution, and solving the algebra after that, we end up with our final answer down here. X, of course, is Jose's speed. He's going 30 miles per hour also.